started. So I'm Lily, for those who I haven't met before. I'm a postdoc. I work with Daniel, and he's had to run to a meeting with the dean. So I have got the delight to introduce Sreekar. And so I'm just going to do your little bio. So he did his honours in India, a master's degree in China, and obtained his PhD at the University of Adelaide. And he's moved through a series of postdocs at different places from Czechia, Singapore, and now at the University of Queensland, where he's mapping biodiversity risks to mining and validating these risks using data on lease approval times. Sreekar's also an avid birder, and I can personally attest to the effectiveness of going birding with Sreekar, because you can look at like a dot in the distance and be like, what's that? And he'll tell you what it is with like 100% accuracy. So if we could welcome him to give so much thanks.
Thanks, guys. Thanks for the opportunity. So I'm gonna talk briefly about like what I've done in the past, and then I'll discuss about the most recent work, which is currently under major revision. I looked at the opportunities, conservation opportunities for effective protected area management, and then discuss briefly about what I'm gonna do at UQ. All right. So it all started when I was an honor student down there in southern Western Ghats, where I was sent to study bird diversity in tea plantations. These are like very old tea plantations, 150 to 200 years old, and then you have these linear strips called windbreaks in these tea plantations. So the windbreaks are usually used to protect the tea from wind damage, the tea leaves. These are so old that these windbreaks, they're kind of transformed into rainforests, and they have a like all kind of fauna. They have like elephants in there, and they have like gore, and there are a lot of interesting stuff. That was my first start. I went there, and then conducted a survey where I looked at windbreaks and compared it with rainforests. And to my surprise, we found that windbreaks and primary rainforests have similar diversity, and they also have like similar quality. So we thought these kind of landscapes are quite important for conserving bird diversity, especially the threatened species. So that's when I went much deeper and studied these whole agricultural landscapes for a good 6-7 years in Sri Lanka and in India, where I've surveyed agricultural landscapes and rainforests across an elevation gradient from sea level to up to 2,700 meters. And I looked at like a bunch of metrics. I looked at turnover, I looked at phylogenetic structure and diversity. I looked at how endemic species are working in it. To put it in short, like these agricultural landscapes are extremely important. As you can see, like these, if you go into these agricultural landscapes and you record birds, around 50% of the birds in these old agricultural landscapes tend to be forest species, and around 10% of all the birds you've recorded there are threatened species. If you go compare it with rainforests, around 20% of the birds you record are threatened species, and you have 10 species. Although these agricultural landscapes are not as good as rainforests, they still have very important conservation value. That's what we've highlighted until we went from Fa. Fa was at the time working with David Wilco from those at the Princeton lab, where they look at production landscapes all over the world. So she came up with this idea of comparing these ancient agricultural landscapes and these new agricultural landscapes all over the world. So we contributed data from Western Ghats, Sri Lanka, China, and Australia. I was doing my PhD in Australia, and I worked in agricultural landscapes near Lismore and Byron Bay. And then what you could see, let me explain this graph. So it's an assemblage level response ratio. Negative values means the assemblages are affected by agricultural deforestation. Positive values means they're less affected by agricultural deforestation. As you can see, like if the agricultural history is there's not much agricultural history, assemblages tend to be more affected. And as you see, like older agricultural landscapes, assemblages tend to be less affected by landscape. I'm just showing you the agricultural history That was our interest, but also seasonality and the amount of forest in the agricultural landscape played an important role. Then I moved to China to look at these new agricultural landscapes because this study showed that new agricultural landscapes are more affected. I wanted to see if there's a difference of pattern what I've seen in India and Sri Lanka, what was in this landscape in China. This is Sreekar, which is on the borders of Myanmar and Laos. It was almost a complete rainforest in the 1970s, and then there was a rubber boom, and then converted into a matrix of forests and rubber plantations. So I went to study biodiversity in these landscapes, and what I found was there was not many birds in the agricultural landscape. I was a bit confused. Is it because things are recently deforested and a new agricultural landscape? So there are no biodiversity before because there was another threat in the landscape. So I built this species area model and developed this slightly to make sure we can start using the effects of hunting and deforestation. And we show that around 25% of the birds are being affected by hunting, and frugivores are especially affected by hunting. Almost 50% of the birds extirpated are caused due to hunting. This model works really well, I think, because if you see understory species, they're mostly affected by deforestation and not hunting, which is kind of true because if you look at the hunters in these landscapes, they have these huge homemade shotguns, which are like 2 meters in height, and they tend to shoot vertically, very horizontally. So they didn't really go for these understory insectivore species, which tend to be small, and they went for the frugivores, which are high up and which is very more region. So after that, of course, when we're looking at hunting, it seems to be an important problem. I shifted my focus more work with hunting, and then we worked with mammals because mammals are affected by hunting, and we used Bayesian multi-species occurrence modeling and interviews with local hunters to see how mammals are being accepted in the landscape. At the same time, we also did this big review on hunting in Southeast Asia when I first wrote to Matt Luskin when he was working on hunting in all common space in Southeast Asia. At the same time, I also wrote an opinion letter. I was young and I was a bit rebellious, I guess. So there was this push to expand the protected area network is still happening. But at that time, the goal was to increase the protected area network to 17%. So there was this there were new protected areas coming everywhere. As the protected areas have been expanding, the finances are not being expanded so much. So you can see the dilution in the management. So already a lot of threats here was the point of establishing new protected areas if you don't manage the existing one. That was the question I asked. It might work well in some regions, might not work well in some other regions. So this was again, this caused another shift. This is when I really moved into impact evaluation in that conservation policy studies. And I mostly concentrated in Southeast Asia. So what I did was I took all the recently established protected areas in Southeast Asia and used a synthetic control method to look at which ones are being effective and which ones are not being effective. See, I'll tell you how synthetic controls work. It's kind of like a linear model. So it's actually quite simple. If you look at a linear model, I guess everyone knows how a linear model works. Y is equal to m1x1 plus m2x2. It's kind of the same here. You see, there's this predicted area. The m1 is the w1, x1 is the other patch. So this is the protected area patch, which is being turned into a protected area, and then you look at other forest patches around which are not being protected. You weigh them in such a way that they behave like the protected area. So it's a kind of a synthetic protected area. So the model is built before the protected area has been established. So this is what has been observed in the protected area, and then you build this synthetic protected area, which kind of follows the pattern of what happened in that particular landscape. And once the protected area is being established, you can compare the observed with the synthetic. That's how you know what would have happened if the protected area has not been established. So you can see an example of an effective protected area and an ineffective protected area. In an ineffective protected area, you can see like the synthetic and observed continue to be the same, but in an effective one, they kind of diverge. So that would be the protected area effect in this. You can also calculate the management intervention. So I went and evaluated around 88 protected areas in Southeast Asia. And also the good thing of synthetic controls is like you model one protected area after another rather than just grouping them into one. It's kind of tend to do when you're doing other impact evaluation like that. So we found on the 88 protected areas that evaluated 41 were effective and 47 were not effective. And you could use something like a null model to get a key value of the effectiveness. So what we do is like you take all the unprotected patches that you're comparing with and just make a null assumption that it is being protected and run the model again. So it kind of tells you like if the pattern that you're seeing is by random chance or is not by random chance. So we've found 41 effective and 47 ineffective protected areas, and the effective ones have been doing well, obviously, and they've averted around 85,000 hectares of forest loss in Southeast Asia, and they help to protect the habitat of 189 threatened bird species. But the ineffective one on the other side, it kind of caused a loss of around 80,000 hectares of forest, and even more birds and mammals are being threatened because of these ineffective areas. Especially concerning are some of these species like the white-brown nuthatch serum mass level and the very famous cebu flower. I wish I could see one. No one has seen it for the last 10 years, I think. But we think it's still around. So all these protected areas, all of these species only occur in that one specific protected area that they're being ineffective. So so we need to look for opportunities for making them more effective, and also making these protected areas effective has other benefits. Like Laos aims to reduce around 1.5 million tons of carbon dioxide emissions per year from land use change. So the protected areas can help. Like this one protected area in Laos, emits around 500,000 tons of carbon dioxide emissions per year. So it's kind of half of the targets that Laos set for itself. So Courtney is not here, but Courtney published a paper where she looked at how much does it cost to run a protected area. It costs around $6.8 per hectare per year. So if we look at all the ineffective protected areas and amount of forest within, you need around $10 million per year to effectively manage these protected areas. So where do you get all this money from? So we were looking at like if there's a possibility of like using carbon credits to improve the management of these protected areas. So if carbon credits come into play and you look at the additional management as an additionality, and the current carbon price is around $5.8 per ton for carbon dioxide equivalent, and it is possible to generate around $12 million. It kind of offsets the management cost that's required to make this ineffective protected areas effective. It's just an idea. It's just theory. There's a carbon credit market is very weird. So there's a good idea and policy to go in, and we've been trying to push it with the policymakers. Let's see how it goes. All right, and that's my last recent study. Right now, I'm in Laura Santos' lab. I'm land use mining and biodiversity conservation group. That's what I'm doing. Land use change, mining, and biodiversity conservation. The two aspects of my research work at Laura's lab. First one is to map biodiversity versus mining. So I'm making two different maps. One is the biodiversity impact, where biodiversity have the highest impact, lowest impact, and the uncertainties of that impact. So I'm making an uncertainty map and the biodiversity. I didn't put a legend there because it's still invalidated. It might be rubbish. I'm just like 4 months into my postdoc, so these are some of the models I've been building. Kind of says that the red ones are the ones with the highest biodiversity impact, and the one with the dark blue where the highest uncertainty is. And then I'm also validating this risk using data from on number of days it takes to get a mine approved. Kind of in general, you want the mine approved really fast because there's a lot of risks if it's delayed. Currently, the mine approval rates are anywhere between 60 days to around 3,000 days, and the average is around 800 days. So we were trying to figure out if like the higher if lease times are higher at regions where the biodiversity impacts are higher because you have a lot more paperwork and other things to do. So that's the validation work that I've been working on. I would like to thank all my colleagues and my PhD and postdoc mentor, my master's advisors, my postdoc advisor, my postdoc mentor, and all my collaborators. Thank you.